This is problem 7 out of the chapter 7 homework, problem 11 out of the textbook. And this problem has two blocks being held together with a compressed spring on the surface of a slippery table. So that's telling us that there's not much friction. One block has 3 times the inertia as the other. When the blocks are released, the spring pushes away. And then the question is, what's the ratio of the kinetic energies after the release? So there's the smaller mass on top and the bigger mass on the bottom. So let's think about this. We've got two things that are being held together by a spring. We've got M and 3M. And the spring has been compressed, and then it releases and pushes them apart, and they spring away. So this one goes that way, and that one goes that way. What can you tell me about the velocities of those two objects? What do we know going back to when we first started talking about momentum and inertia? What we learned is that it doesn't matter what kind of interaction it is. It doesn't matter whether it's springs or explosions or collisions or whatever. In every interaction, there's two objects, and if one of them has a velocity change, the other velocity change will follow the ratio of the inertias. So we're going to have a final velocity for this one and a final velocity for this one. I'm going to label them V1 and V3 to go along with their masses. And we know that this velocity is going to be bigger because that object is lighter. It resists changes less, and therefore it will go faster. Okay, so we know that M over 3M is going to be minus delta V1 delta V3. And that's flipped because that's what makes it so that the lighter one goes faster. And it's minus because they're going opposite directions. Well, both of them start out at rest. So if they started out at rest, their initial velocities were 0. In that case, their changes are equal to their final values. So this is really saying that the final value of V3 and the final value of V1 are going to follow the ratio of 1 to 3. And those m's actually cancel out too. So that's 1 over 3 equals minus V3 over V1, which means, solving that, V3 is negative 1/3 of V1. I'm having trouble with this pen writing clearly. All right, so V3 is 1/3 of V1. The negative is because they're going opposite directions. Okay, but the question asks about the kinetic energies. So what I want is K1 over K3. That's going to be 1/2 mv1 squared over 1/2 mv3 squared. I'm just writing. So K1 is 1/2 mv1 squared. K3 is 1/2 mv3 squared. That's what that ratio is. So whatever I get by simplifying this is going to be the thing I want. Well, I could see that the 1/2 and the 1/2 and the m all cancel out. Oh, there should be a 3 there. But the 3 doesn't. So that means K1 over K3 is V1 squared over 3 V3 squared. Okay, that looks good. But then I also know that I just figured out what's the relationship between V3 and V1. There's this 1/3 here. So that's going to give me, eliminating a variable, K1 over K3 is V1 squared over 3 times negative V1 over 3 squared. All right, And now I can simplify that a little bit. That negative is going to turn into a positive because of the squared. The v1 and the square are going to make v1 squared. That's going to cancel with that. The 3, and I've got a 1/3 squared on the bottom of the fraction. That's going to flip up to the top, and I'm going to get 9/3, which equals 3. So k1 over k3 is equal to 3. That tells us that the smaller object takes 3 times as much kinetic energy away. And that's because it's got 3 times the velocity, and the velocity gets squared. It's not 9 times the kinetic energy because the bigger mass also partially gives more energy to the bigger object.